Okay, we are going to learn how to add binary so we can show how computers perform arithmetic, and by computers I mean calculators as well as any computerized device. Now in normal maths we need to remember lots and lots of different rules, or a lot more than we do in computer science. So we remember that 0 plus 0 equals 0, 0 plus 1 equals 1, 0 plus 2 equals 2, and we keep going all the way down till we get to the last one we need to remember, which is 9 plus 9 equals 18. Just the one before that would be 9 plus 8 equals 17. In computer science we need to know far fewer than that. We just need to know these four: 0 plus 0, 0 plus 1, 1 plus 1, and 1 plus 1 plus 1. The other rules that are involved in adding binary are really similar to denary, and so are the answers to this, first of all. So if we have a look at these, so in denary, in decimal, 0 plus 0 equals 0, 0 plus 1 equals 1, and 1 plus 1 equals 2, and 1 plus 1 plus 1 equals 3. And if we were going to do that in computer science, we would represent the answers. If I take 0, I want to represent that as binary, that's just all zeros. Okay? And actually, just like normal maths, I'm not interested in these zeros. I'm only interested in the first two, which is my answer, and this one here, this 0 here, is my carry. Just like you have a carry in normal maths, and I'll show you what those are in a minute. So let's look at the next one. So again, I'm not going to bother with these, but how do I represent 1 in binary with 2 bits? Well, the 2 would be off and the 1 would be on. That's 1 in binary. I've got my answer and I've got my carry. What about 2? Well, 2 being on, don't care about 128 to 4, but 2 is 1 is on and 0 is off. And again, the first one, or the first digit here, that's my carry bit, just like we have a carry bit in normal maths. Same, let's think about 3. How do we represent 3 in binary using 2 bits? So I'm not interested in all of these, I'm just interested in the 2 and the 1 bit. So I'll let you think about that for a second. And yeah, and hopefully what you've got is 1 and 1, with the 1 being our carry bit. Now, if I look at these two answers, this looks like 10 in normal maths, and this one, the answer to 3, looks like 11. And that's really key because we're going to treat them the same way we would treat 10 and 11 in normal maths. So let's look at some examples. So we've got our rules here that we just talked about. So we've got 0 plus 0 equals 0, which is 0 in binary, 0 plus 1, which is 1, which is 1 in binary, 1 plus 1, which is 2, which in binary looks a bit like 10, which is the 2 bit on, and the 0 being and the 1 being off. And then we've got 3, which is looks like a little bit like 11, which is the 2 bit being on and the 1 bit being on. So let's take some binary numbers. Let's do 0, 0, 0, 1, 0, 0, 1, 1 as our fast number, and then we're going to add 0, 0, 0, 0, 1, 1, 1, 0. Okay, so let's have a look at this. So I'm going to just draw a line, set it out like I would a maths question. Now we use the green, and we're going to take each column one at a time. So I'm going to take my first column, which is my ones column, starting at the least significant bit, my least significant bit, like we would start at the least significant digit in adding normal maths, the lowest place value, and we're going to add them together using our rules. So 1 plus 0, 1 plus 0, or 0 plus 1 gives me 1, which is just binary in normal maths, and in binary and decimal, so it's normal maths. Let's go on to the next column. So let's now have a look at my next column, which is my 2's. And now I've got 1 plus 1. 1 plus 1 gives me 2, which is 2 in binaries looks very much like 10. So it's the 0 being on in the column that we want, and then the 1 being on. Now, I said that we treat it like 10. Now, in normal maths, we wouldn't put the 10 or the 10s in that column. What we'd do is we would carry it. So I'm going to rub out here, and we're going to carry it over to the next column. So now in the next column that we're going to go to now, I've got a 1 plus a 0 plus a 1. And again, that is this line here, because I've got 1 plus 1 gives me 2. My answer is 2. So then it becomes 1 plus 1, which is 2, which the answer looks like 10, because it's the 2 column on and the 1 column off. So again, what I'm going to do is I'm going to put my answer down. Oh, wrong colour for my answer. And then I'm going to take my carry over. And I'll repeat again. I've now got 2 in this column. So it's 0. And my carry, my 10 goes over, my 2 goes over. Again, I've got the same thing here. I've got a 0 and then a carry bit of 1. And then my next column, I've got only got 1 in this column. Should highlight this. I've got 1 in this column. So my answer is 1. So there's 1 here, and then I can fill out the rest with zeros. Now what we can do in here is we can check our answer. So if I take this number here, 16 plus 2 plus 1, that number is 19. And if I take this number here, I've got 8 plus 4, which is 12, excuse me, plus another 2, which is 14. So if I add those together in normal maths, what I end up with is 33. And if I look now at this number here, that equals 32 is on, plus 1 is on, which equals 33. So my answer is correct. Let's try one more, remembering our rules up here. So let's take 2 numbers. Let's do 0, 0, 0, 1, 1, 1, 0, 0. So let's just add that all up. So that's 28. And let's take another number, which I'll do in green. 0, 0, 0, 1, 1, 0, 0, 0. Let's add these together. Let's draw a line underneath. And just so we're aware that the green number, 16 plus 8 is 24. And we're going to use that to check later on. Let's now not use our rules and highlight them. We're going to do 0 plus 0 gives me 0. The next 0 plus 0 gives me 0. 1 plus 0 gives me 1, which is just 1. Here I've got 1 plus 1, which gives me 2, which in binary is 0, and carry the 1. Now I've got this column, which has got 1 plus 1 plus 1, which in normal maths would give me 3, and 3 in binary is like 11, because you've got the 2 on and the 1 on, which make 3. So that's 1, and then I carry my 1, and now I've got 1 plus 0 plus 0, which is 1, and then my final columns, I've got 0 plus 0. So there I've got my answer here, my answer here. And again, we can check it. 32 plus 16 gives me 48, plus 4 gives me 52. And if I do 24 plus 28, I get 52. So I can see that my answer is correct because I've checked it nice and easily. Right. Okay, so one more example that we're going to do here. And I'm just going to come up with a larger number. And this is going to explain why we get a maths error when we try and add or do calculations with really large calculators on a calculator or on a computer. Let's do 1 0 0 0 0 0 0. So I'm going to try and add these together. Now remember that we do 8-bit. When we talk about an 8-bit computer, what we're actually talking about is a computer with 8 wires that are able to carry electricity on it, which represent each of these numbers in our binary place value. And in an 8-bit computer, there is only 8 wires to carry the let's colour them in yellow, so we don't think of them as zeros, we think of them as bits of electricity flowing through. And I'm going to try and explain what happens when the carry bit goes over as well. So let's take 0 plus 0 gives us 0, 1 plus 0 gives us 1, 0 plus 0 is 0, 0 plus 0 is 0, 0 plus 0 is 0. Now we get to this one. 1 plus 1 gives me 0, which would turn the electricity off in this wire. But in the next wire, what would happen is we'd actually have another wire that connects it over to here, which would send an electron over to this. So we're doubling the amount of electricity on this wire. So we've now got 2 electrons on this wire. So that would be 1 plus 0, which would give us 0 with another carry of 1. And let me just make sure I've written my carries in both columns. And again, what would happen here is that I've got a wire coming off here, going to this wire here, and I'd send another electron over to here with its 1, 2 electrons on this. So I've now got 3 electrons on this wire coming in, and this is how the computer works it out. So 1 plus 1 plus 1 gives me 1, and my carry 1. Now the problem here is I don't have in an 8-bit computer another wire for it to go to. So this electron here comes along, I'll do it in a better colour than that, and it's got nowhere to go. So essentially it gets lost. So we don't get this extra carry bit. So how we show this in maths is we draw another one here, but we circle it and we cross it through, and we draw a line to say that this is an error called overflow, because our electron has overflowed to a wire that doesn't exist, so it's gone missing. So whilst adding binary is very quick and very accurate, it only works within the number of wires you've got in your computer. So an 8-bit computer can only do these 8 place values. A 32-bit computer can keep doubling 32 times, so it can store a much bigger number. And most of your calculators and things like that have 16-bit in them, so they're able to do quite large numbers, but not larger numbers than, I can't remember, like having all the 9s on the screen, which is why we get the maths error. And what we actually mean is happening is that we get an overflow error. So when you get this error on your questions, you have to do this: circle it, cross through the final overflow bit, and label it as overflow. What I want you to do is try these, and what I'm actually going to do, try and make it harder, I'm going to blank out my rules. I want to see if you can do it without them. So I'm going to give you a few minutes to try and do this, and you can pause the video now. If you do want some extra support, here are the rules, but hopefully you pause the video and you did it without the rules. And the answer, and so here are the answers, and again what you can see, hopefully this is what you've got, and what you should see here is that I've done my check and I've checked they are compared to what those binaries add up to. Remembering also that I should have here, I will have an overflow which I've crossed through, and I've written overflow as an error.